I am Dr. Manish Goyal from Department of Physiology, AIIMS Bhubaneswar, Odisha, India. I am presenting my paper on Baroreflex sensitivity assessment using dynamic lag analysis validation study with EuroBaVar dataset. Baroreflex is a critical feedback mechanism that maintains the blood pressure homeostasis. This baroreflex functions through the baroreceptors present in the carotid arteries and the aortic arch. These send signal to the brainstem, which in turn adjusts the heart rate, vascular resistance, and cardiac contractility, maintaining the blood pressure. Baroreflex serves as a prognostic marker in conditions such as hypertension, heart failure, and coronary artery diseases. Traditionally, measurements of baroreflex sensitivity is done using non-invasive methods, utilizing spontaneous fluctuations that occurs even at rest in blood pressure, and the slope between blood pressure and RRI sequences are analyzed to get the baroreflex sensitivity. But in this method, there is an assumption that these two sequences they overlap perfectly to each other, or if there is a lag, that lag remains constant throughout the time of recording. But this is known to be false, and there can be variabilities even in the same person during the same recording session. So we try to develop a new method capturing the dynamic physiological delays in blood pressure and RR intervals series data, and evaluate the performance against traditional methods. So for this, we use the EuroBaVar dataset, which provides standardized blood pressure and RR interval recordings, and we developed MATLAB codes to perform conventional sequence method analysis and spectral analysis. Along with that, we also developed dynamic lag baroreflex sensitivity method, where we introduced physiological delays into it, and we identified more number of sequences because we considered lags ranging from 0 to 5 beats, and we used selection criteria that we conventionally used in the sequence method. And then we compared statistically with the conventional methods using standard statistical tests like mean comparison, correlation analysis, and limits of agreement using the Ball-Dalton plots. Our results showed comparable means with no significant differences and a strong correlation with the conventional sequence method with an R-square values greater than 0.85. The dynamic lag analysis can capture physiologically relevant delays with an average lag of 3.5 heartbeats with minimum variability. Dynamic lag analysis also identified 23% more sequences as compared to the fixed lag method. Their dynamic lag baroreflex sensitivity estimate showed a strong agreement with the traditional sequence method based baroreflex sensitivity estimate, with a mean bias of just 0.03 with narrow limits of agreement. The other measures of baroreflex sensitivity like alpha index and low frequency gain from the spectral analysis also showed good limits of agreement. Baroreflex efficiency index from sequence method and from dynamic lag method also showed good limits of agreement. To conclude, dynamic lag baroreflex sensitivity method demonstrate comparable accuracy with the conventional sequence methods and addresses the key limitations by incorporating physiological delays and nonlinear dynamics into the analysis. It demonstrated a strong agreement with sequence method and was able to give mean lag, which may serve as a marker for coupling between systolic blood pressure and RR intervals for assessing autonomic nervous system functions. Looking ahead, our method can be further developed and standardized for widespread use in the baroreflex assessment. Validating this method across different clinical populations, including patients with heart failure and hypertension, will ensure its broader applicability. This method can be of good prognostic value and be used for cardiovascular risk assessments. Thank you.